Thank you for clicking on my video. If you watch this video, you'll have information about a paper released on the 2nd of March 2022, which is yesterday when I'm doing this, and about two of the hypotheses as to the cause of aging. Listen to a consideration as to what works to reduce the aging of cells and whether that's consistent with either of the hypotheses, and have things to talk about with your healthcare professional. Now, just a standard disclaimer, this is not medical advice. I'm not medically qualified, have a degree in physics but not medicine, been an MP, tech entrepreneur, and I'm a musician, none of which particularly qualify me to talk about biology, but it doesn't disqualify me either. I'm not a doctor, this is not medical advice. I've studied the issues of cellular health to improve my own health, particularly sleep, and I produced this video to be helpful to others with the research I'm doing. My channel is not monetized and I'm not sponsored. I do have a patent application in, but that's not directly relevant to this video anyway. So if you've got anything in the video you'd like to discuss with your doctor, please do so, and don't do things without talking to your doctor, because some things can be helpful or harmful depending on the circumstances and depending on the individual. Anyway, moving on. I've done a really short, if you can't be bothered to stand to the end of the video, this is a too long don't read thing, right? There's a number of interventions which can improve the health of cells, and there are a number of hypotheses as to why cells deteriorate over time. One is that aging is just one of those things that's going to happen. It's programmed or programmatic. Another is there's a vicious circle of molecules being emitted and the failure of stem cells to differentiate. What's clear, however, is that something in the blood causes cells not to differentiate properly, and that was particularly seen in the paper published yesterday. One way of testing whether a hypothesis is valid is to see whether the interventions of the work are consistent with the hypothesis, and I think that substantiates the argument that the molecules being emitted into the blood is the hypothesis that's valid, rather than programmed or programmatic aging. So something in the blood is what drives it. So let's go on to the next video. Go on. Here we go. Anti-aging approaches. There are lots of different things which have been found to improve cellular health, such as things like calorie restriction, concept of hormesis, being hot, cold, hypoxia, oddly enough, that's the hypoxia-induced factors. That, oddly enough, also links to mTOR. Heterochronic parabiosis, which is where you connect the blood supply from a young animal to an old animal and you see what happens. That has been seen to have an effect, has plasma dilution, has had a mild effect. Cellular reprogramming has had some impacts, and there's lots of things that relate to the quality of the health of the mitochondria, such as HIF, infrared, melatonin, that sort of thing. And obviously you've got to have the right micronutrients, because if you haven't got the right chemicals in your body's not going to work so well. So the theory of something in the blood is that your age deteriorates across the body, and it's known that, for mice anyway, a shared blood supply can reduce aging. And in fact, there was a paper released yesterday which looked at that, called Molecular Hallmarks of Heterochronic Parabiosis at Single Cell Resolution. This is the link on Nature's website. And also, that link, by the way, will be at the end. No, I'll put the link in the comments section. It's the only one I'm linking to on this paper. But let's just look at part of what it says. So let's see what it actually says. It says, whereas the effects of aged blood tended to accelerate normal aging changes, young blood both reverses age-related profiles and initiates new pathways. And all the reversal of aging through young blood may be easier to grasp. It will be equally interesting to explore the molecular and functional as well as therapeutic implementations of those distinct pathways. Well, what does it conclude? Well, we knew this already. We knew that something in the blood, either something in young blood that doesn't exist in old blood or vice versa, or a mixture of the two, was something that was one of the causes of cells aging. Now, programmed aging, where it just happens, obviously, if that were to be true, heterochronic parabiosis or plasma dilution wouldn't have an effect, because it's nothing to do with the blood. It's to do with, this is just going to happen, it's in the epigenome, and you've just got to live with it. Now, what you have these sort of zombie cells called called senescent cells, and they pass molecules to the stem cells via the blood. My view is that this reduces a nuclear factor kappa B, which causes a reduction in acetyl-CoA getting to the epigenome in the nucleus, and that is what causes what's seen in that paper. And we saw that in a paper of September last year. So, moving on. Can cellular reprogramming reverse aging? Well, actually, although you can take a program back to being a pluripotent, and a cell back to being a pluripotent cell, I'm not sure that once it's got there in the wrong molecular environment, it will actually create the cell that you want. And we've seen, with the paper just now and various other things, we've seen lots of examples of why it's obviously a problem of some sort. So, moving swiftly on, what I think is the vicious circle is that we have these senescent cells which issue a thing called for the purpose of inflammation, but there's a slight subtlety there, and senescence associated secretory phenotype, so they send out these chemicals, one of which is interleukin 10, and that goes up, and that reduces the amount of nuclear factor kappa B, which then reduces the amount of a gene called SLC25A1, which reduces the amount of citrate carriers, which means there's less acetyl-CoA in the nucleus, and the stem cells fail to be stem cells and become senescent cells, and we go back to issuing this SASP sort of inflammation, except there's a subtlety there, which I'll come to. That obviously fits with the Gumpertz formula, and I've gone into more detail that in another video, but I wanted to do this particular video because of the paper that came out yesterday. So, I think it's interleukin 10. And the reason I think it's interleukin 10 that is in the that's the thing that starts it all off, is that is in SASP. We know what's in SASP, and interleukin 10 is in it. It inhibits nuclear factor kappa beta. That's the reason I picked it. I looked for the things in SASP that inhibited nuclear factor kappa B rather. Oddly enough, interleukin 10 is anti-inflammatory. So when you think about it, it's not necessarily the first thing you would look at for causing stem cells not to differentiate. And it is really quite hard to test for at the moment. To do a blood test, you actually have to freeze the blood there and then, because obviously it deteriorates in the blood. I haven't really looked at that in massive detail, but the fact that you have to freeze the blood implies something like that. But we don't have the proof as yet. But I still think, in terms of the whodunit type thing, it's quite likely to be interleukin 10. And obviously the thing to do is test and see whether it is or isn't. There is a difficulty, of course, which is interleukin 10 does reduce the effects of other aspects of SASP. So just trying to take the interleukin 10 out of blood is not necessarily the way of improving people's health. It requires a mixture of activities, including reducing the number of senescent cells and all sorts of things, and improving the way the mitochondria work, which most of the things people do to improve their health, the anti-aging things as they're called, are actually things which are improving the health of the cells, particularly the health of the mitochondria and things like autophagy and the like. So there you go. I think it's interleukin 10. And thank you for watching my video.